All right, let's look at the empirical and theoretical probabilities. All right, so empirical probability is the probability assignment which is based on collected data. And the theoretical probability is based on something called the equally likely assumption. Equally likely assumption. This is assumption that each outcome in the sample space is equally likely to happen. All right, so let's look at the empirical probability first. Let's dive right into an example. All right, so let's look at this simple example. Let's say you roll a die, right? Just a standard die, right? So what we do is we do sufficiently many times to collect the data. Let's say roll a die 100 times, right? Then you collected the data. We get a 1 20 times out of 100, and we get 2 15 times, 3 13 times, 4 17 times, 5 25 times, and 6 10 times. All right, and based on the collected data, we can assign probability. All right, so 20 out of 100, so probability of getting a 1 is 20 over 100. And we can, if you want decimal numbers, we can do that too. So say 0.2. Getting a 2 would be 0.15. And getting a 3 would be 0.13. And getting a 4 would be 0.17. And getting a 5 would be 0.25. And getting a 6 would be 0.1. All right. So the probability assignment based on collected data, and we're going to use those as a probability for each outcome. And this kind of probability is called empirical probability. All right. And in general, so probability of event can be determined by, divided by, number of trials, so it's going to be n, right? And then whatever the frequency of that event happening, like if the event is getting a 1, would be it happens 20 times. So 20 over n, which was 100 in this case, will determine the probability of an event. All right. On the other hand, theoretical probability doesn't require any collected data. We're going to just assume that each outcome in the sample space is equally likely to happen. Right? So with that assumption, let's say rolling a die, right, getting a 1 is same probability as getting a 2, 3, 4, 5, and 6. Right? So there are 6 possibilities, and probability is equally distributed. So it's 1 divided by 6, so it's going to be 1/6 is the probability of each outcome. Right? So in general, maybe I should write that. In general, right, probability of an event can be easily found by, so it's going to be just a number of outcomes in the sample space times number of outcomes in the event E. That will give you the probability of an event E in theoretical probability. All right. So the biggest difference is empirical probability is determined based on collected data, and the theoretical probability is going to be based on equally likely assumption. Right? From now on, unless indicated, we're going to do a theoretical probability, but there will some problems involving empirical probability as well. All right, that's it. I hope that this was clear.